So after discussing ranking functions in my SQL, we have to discuss aggregate window functions. So in aggregate window functions, sum, average, count, maximum and minimum. These are aggregate functions that are usually used in normal SQL queries also. For example, suppose we have to write what is the minimum unit price, maximum unit price, okay, minimum unit price, maximum unit price, and what is the average unit price. So we have to write them. So from product. So these three aggregate functions, if you will run them, you will get the answer that minimum price is this, maximum price is this, and so on. But these can be used with window functions also. So first we will now try to find out cumulative order amount per customer, or basically cumulative freight amount per customer, which is running total. So this question will be asked a lot in statistics or data analysis, that find the running total of order amounts per customer. In our case, it will be running total of the freight amount, because we are not joining tables. So if you see the orders table, every customer has ordered some product and their freight charges are there. So this is basically the freight charges for every order, like in every row, freight charges are given. The question is asking, calculate running total, consider freight amount, okay? Calculate running total of freight amount per customer. So if we have to calculate running total, so there we will use over sum, okay? We will use sum freight, and we will partition by customer ID. So whenever per customer or per order, these type of things will be written, like for each customer or for each category ID. In that case, you learnt in the previous part that we use partition by. So we have to partition the results, or basically we have to show the results partitioning by customer ID. That means for first customer ID, for second, for third, for fifth. So first we will show for the first customer, then we will show for the second, depending upon some condition. So that's what we are doing here. Here also command is very simple. The only thing that is changed is that in previous part we used rank, dense rank, or row number functions. Here we are using sum. So first we will select customer ID, order ID, order date. We will select these three. Then fourth column is running total, because in question it is asked calculate running total of order amounts per customer. So then what we will do, we will write sum of freight. We are considering that freight is that amount. So if order amount is given, so you can directly write the order amount. We are writing select customer ID, order date, and sum of freight. Sum of freight will sum all the freight charges paid by one customer. That's why, so when we'll write sum freight over partition by customer ID. So we are partitioning the results by customer ID. Earlier we used group by. In group by also, suppose you want to show category wise total unit price. So there also we used sum unit price grouped by customer ID. Here in window functions, when you have to find running total, we are writing sum freight over, and here we are using partition by instead of group by. So in bracket then we will write order by order date, because in question it is asked running total of order amount per customer. Okay, so we are ordering by order date, so that for every date starting from the first date till the last date we'll get the running total. So first let's run the command. When you will run the command, you will see that customer ID alpha paid a running total of 40, then this customer paid a running total of 41.63. Okay, then this is for this second customer, ANAT or whatever its name. So running total 1.6, 45, then 57, and then finally 97.42. Here is one more example, sum. This function calculates the sum of columns value within a window. Okay, so what is happening here is first order ID was made by customer ID 101. Here also we have selected order ID, customer ID, and order amount, and then we are doing sum of order amount over order by order date. Here we are not grouping by customer ID. Here we are just ordering by order date as total amount. Now what is happening here is for the first order, okay, for the first order that we are seeing here, so in the first order you can see that customer ID is 101 and order amount is 100. Here we have not grouped or partitioned by any customer ID, so this is just like a column. So what we are considering is order ID and order amount. So for order ID 1, order amount is 100. For order ID 2, order amount is 200. Here total amount is 100, but here the total amount is 300. So are you getting this? Here the total amount is 100 because there is nothing above it. So total amount till now is 100. What is the running total till this row? What is the running total of order amount till this row? 100, right? But what is the running total of order amount till this row? Row number 2. So this running total amount 300 comes from 100 plus 200. Then in the third row, order amount is 300. So 300 plus 200 plus 100, 600. This is how this running total is calculated. You can write order ID also. You can write customer ID also. Whatever you want to write. But if you have to start from first date to last date and see the total amount, this is basically telling what? When we receive first order, we got 100 rupees. When we receive second order, we got 300 rupees. When we receive third order, we got 600 rupees, right? It's like that. What is the total amount collected after 7 orders? This is the answer. So total amount collected after 7 orders was 1550 rupees. So this is how you will answer, right? This is why this total amount is there. So here in this example also, like what we did earlier, here in this example also, in orders, when we are calculating the freight charges paid by each customer, it is like that. If I remove partition by customer ID here just for now, so you can see first we got 32, okay, then we got 43, then we got 151, then 151. So it is, in this case it is different. In this case we are adding freight over order by order date as running total. Okay, that's why here what we did was we did partition by customer ID. So it is like that. But to understand it in a better way, this is the example. So this was the original data. In original data, order ID and order date were given. Okay, यहाँ पे you can see that in original data, order date is given. Okay, so you will select order ID, customer ID, order amount. How will you write that? So you'll write some, yeah, you will write something like select
order ID,
customer ID, comma order amount, because we don't need order date in the answer, right? So we are doing order ID, customer ID, order date. Then fourth value will be your running total. So
sum.
To find that, you will write sum of order amount. Okay. So you will write sum of order amount
over,
and you can actually write order amount here. By mistake I wrote order date. You have to write order amount, sum order amount over, and then
over order by,
and then you will write order by, and whatever is that value, order date. Okay,
as a total,
and then you will write as running total, or whatever you want to write it from, and whatever this table is, let's say orders. Okay, so this will be the command. Suppose if you have to partition by customer ID, like for every customer you have to do that, so then you will write over partition by over partition by customer ID, order by order date. So this way you can write. And what you can do, you can copy this type of data, like after the result is calculated. So we can copy the data and use something like Power BI. So after just copying it, you can enter data here and load the data. I'm just giving one example like what will happen. So what is the purpose of this cumulative thing? So now here we can create a line chart, for example, like this. And in the line chart on x-axis, we can take the order ID, and on y-axis we can take the total amount. So like this will tell us the cumulative sum after each order, and we can enable data label. So when I will teach you Power BI, I will explain all of this. So this way you will see after each order ID what is the total amount, and you can create a simple line chart or area chart also. So this is something. And actually if you will put order amount, you will see order amount gives you a different indication. Order amount just tells you that after for each order how much did we earn, like for each order. But this cumulative total or this running total will tell you that after each order what was the total earning, considering previous earning also. So sum of order amount is basically telling for each order what is the order amount. So we can change it as a line and clustered chart, and we can take the cumulative total here. So this will be like a continuous value that after each order what was the total earned amount, and for each order what was the total earned amount. So this kind of chart can be created. I will explain this when we will run Power BI, when you guys will learn Power BI. This is a simple chart. And what is the query for this? You just saw the query. Query is this, that select order ID, customer ID, amount. So that's why SQL is very important. Like obviously SQL is not giving us this answer, giving us this chart directly, but at least SQL is giving us the answer like this. What is the sum of total amount? Okay. So the query for this will be simply this. We can add insert and we can add a text box also. So this will be that query, and then we will make it bold. We can increase its font size from here. These things I will explain later, but I'm just doing this. Okay. To show you that we can answer questions like this also, like this as well. So this is select order ID, customer ID, order amount. Okay. And this is one window function. Okay. This is my SQL window function, and similarly we can use other aggregate window functions also. These are aggregate functions. In aggregate functions we have average, minimum, maximum. So we have those examples also. So you can try them as well. So this is cumulative order amount, cumulative something. Another example will be, so this is for calculating the cumulative something. So explanation is sum of freight over calculates the running total of shipping cost, that is freight. Partition by customer ID resets the total for each customer, and order by order date ensures the cumulative sum follows the chronological order. Chronological order means by time. Another question that can be asked in this type of chapters is moving average. Find the moving average. Okay. So calculate a 3-order moving average of freight cost. So 3-order moving average, what will be that? So when moving average is asked, so you will use the average function. Okay. So select order ID, customer ID, order date, and freight. So this much is like a simple selection. For finding out the moving average, you will write average freight over, and then you will write partition by customer ID, order by order date. This much is same as above, only we have replaced sum with average. But here we are using rows between two preceding and current row. So this is the statement, like rows between two preceding and current row as moving average. What is meaning of this? Rows between two preceding and current row ensures only the last 3 orders including the current are considered. So basically moving average, in this moving average, if you will just write up to this point, so this will be moving average. So let's write up to this point only. So here we are writing partition by, and here partition by customer ID as moving average. I am just writing as moving average from orders. Okay. So when you will write that, so you will actually see that it is showing for alpha up to this point what is the moving average, up to this point what is the moving average. But if you just write it like this, order by order date, rows between preceding two, so for that I have already written the rows between two preceding and this. Some commands are like not that easy to remember, that's why more practice will be required. But now what is happening, on the basis of last 2 or last 3 orders, it is giving us this example. Next is finding previous order date. Like there is another function that is called lag function, lead lag. Okay. So lead and lag means what? Like previous order date lag, next order date lead. So find the previous order date for each order per customer. Like here we are saying that if the customer has ordered something, so what was the previous order date for this customer and what is the current order date? Okay, so first I am writing and giving the answer and then we'll understand. So here you can see for alpha, because alpha made the first order on 16/3/98, there was no previous order date because this was the first order. But then when alpha made the second order on 9/4, so this was on 16 March, this was on 9 April. So on 9 April, what was the previous order date? 16 March. So are you able to understand this answer first of all? So basically this is finding previous order date. For that we write select order ID, customer ID, order date and lag order date over. Then in over, you know, this is common, that partition by customer ID, order by order date as previous date. In lead, what will happen? Find the next order date. So if you will simply change this lag to lead, okay, if you will change, so if you will just change the lag to lead, it will give you the next. So when this customer ordered 16th of March, this customer's next order was on 9th of April. It is telling like that. Then after 9th, this customer never ordered. Okay, that's why none. So lag or lead is the same thing. What will be the difference between lag and lead? Positions will be changed. It's just like it is telling you what was the last date when this customer ordered, isn't it? That this was the last date when this customer ordered. After this customer never ordered, right? So what was the last order date of this customer? First order date of this customer. And here we just have to write next order date, like that will be the better answer. So that's why you will write next order date. So this is called lead and lag functions. Lead and lag functions are very important, and lead and lag functions are grouped as analytical functions. Okay. Then third analytical function is NTILE. NTILE, grouping order into buckets. NTILE. Here also we have given examples. NTILE. This functions divides a result set into a specified number of groups and assigns a group number to each row. Okay. So first let's see the example. So in the below example, we are dividing the order into 3 groups based on the order amount. So here you can see in NTILE, so like you are doing over order by order amount as order group from orders. So basically what we are saying is, if you will write NTILE 3, so what it will do, it will take first 3 rows and give it group number 1, second 3 rows, next 3 rows group number 2, and then other values group number 3. So this will order on the basis of NTILE value, whatever is given inside NTILE. Let's see another example. Divide orders into 4 equal size buckets for each customer. Okay, so here you are writing NTILE 4 over. So when you are writing NTILE 4, so it assigns order into 4 equal size groups. Let's say there are 800 orders. Let's say there are 800 orders. So if you want to group them, so some orders will be 200 orders will be in group 1, next 200 orders will be in group 2, next 200 in group 3, and last 200 in group 4. So that will be the case. And we don't have to worry. We'll cover this topic once more if needed. I know these type of commands for beginners can be overwhelming, like too much to handle, but this is how it is happening. So you can see annotator has ordered 3 times. So 1, 2, 3, 4, right? 4 equal groups. It is doing that. What if we remove partition by customer ID from here? So now it will give group number 1, group number 2, like that. You can see we have around 833. Let's say we are using 500 of them. We are seeing 500 of them. You can see first 200 something will be group number 1, then next 200 something will be group number 2, and so on. So these are the commands. What you have to do, you already have the Northwind installed, like we have explained how to install all of that. Try these things, try to understand what is happening here, and the purpose of these 4 are very clear. Purpose is rank. You know that it will give unique rank to each row, but if 2 values are equal, it will give the same rank, and skip the rank. Dense rank will give the unique row rank to each row, but if the ranks are equal, it will give them same rank, but it will not skip the rank, it will assign the next rank, which we discussed in previous examples. Row number, no matter what, it will give unique row number to each row, starting from 1 to whatever value you have provided. In aggregate functions like sum or average, these are used to count moving total or moving average, or running total or moving average. These are window functions. In analytical functions, you have lead, lag, and NTILE. So lead, lag, and NTILE. Lead, suppose you have to find the previous date of the very customer. Lag, you have to find the next date of that very customer. NTILE, you have to group total number of orders into 4 equal groups, 3 equal groups, 20 equal groups. Like if we write NTILE 20 here, so every order will be ranked on the basis of order date into 20 groups. So if you write 20 here, so you will see that it will do that. So you can see for 250 that 1, 2, 3, 4. So it will assign that. So these are the functions. We'll come up with more examples, but first read more about them. Like here we have given SQL examples. Here I have explained a little bit more what this function does, what this function does. I will provide you both the URLs with both examples. Check them from your end and make sure that you understand these concepts. And that's why here we have different set of questions, here we have different set of questions. So just go through them, and whatever doubts you have, we will discuss in the next class.